To begin with electrical safety. Electrical grounding is used to protect technicians and equipment in the case of electrical insulation failure. Electrical grounding provides an alternate path for the electricity. This is often referred to as a return to earth. All electrical systems should be connected to properly grounded circuits. This helps to protect both the technician and the equipment. Then there's ESD, or electrostatic discharge. ESD is caused when two electrically charged objects that have different amounts of electrical charge come into contact, creating a sudden flow of energy between the objects as they normalize the levels. This is a static discharge. ESD can damage sensitive components, particularly the CPU and/or your random access memory. Using an ESD mat helps to reduce the chances of ESD. Using an ESD strap will further reduce the chances for ESD. The strap goes around the wrist of the technician and then is clipped to a ground source, usually to an exposed metal surface inside of a piece of equipment's case. You should always practice self-grounding. Self-grounding is a normalization technique used to equalize the amount of electrical charge between the worker and the equipment being worked on. After the case has been opened and the ESD strap is attached to a ground source, touch an exposed metal surface inside the case before actually touching any of the components. This will normalize the electrical charge between you and the equipment that you're working on. In some cases, additional equipment grounding may be necessary. In case of an electrical fire, unplug the power source or turn off the circuit breaker. Always use a Class C or multi-class fire extinguisher on electrical fires. Never use water. You run the risk of electrocution and damaging that equipment even more than the fire is already doing. So let's talk about fire suppression systems. Building codes often call for the installation of fire suppression systems, and there are several different types of common systems. There's the wet pipe. The overhead pipes are pressurized and contain water all of the time. Then there's the dry pipe. The pipes are not pressurized. The water is contained in a holding tank until a fire breaks out, and then it is pumped to the area where it needs to be dispersed. There are pre-action types of fire suppression systems. They're similar to a dry pipe system, but the sprinkler head contains a thermal fusible link that must melt before the water is released. Then there's the deluge fire suppression system. These are designed to release a large amount of water in a short amount of time into a predefined space. The deluge system is the least desirable option for electrical components. On the other hand, a halon type system is the most desirable type of fire suppression system for electrical components. Halon is a non-conducting, volatile gaseous chemical. It works by chemically disrupting the combustion process. Halon does not leave a residue upon evaporation, and unlike water, halon will not ruin electrical components. It is safe for exposure to humans in limited amounts for a limited amount of time. Halon is also environmentally safe. It's also known as a clean agent. Now it's time to move on to installation safety. First up is using proper lifting techniques. Bend at the knees, not at the waist. Keep your head up when lifting. Avoid twisting when carrying items. If the item is heavy or awkward, request help in lifting it. Also remember, most companies establish weight limitations. So if you're going to lift something that is going to exceed that weight limitation, ask for help. More than likely, you are going to need to install equipment racks at some point in time or another. Racks are used to help create a clean, organized environment, especially when they're used with proper cable management techniques. Racks are designed to provide sufficient airflow for the electrical components that are placed in them. When assembling and installing racks, always follow the manufacturer's instructions. Always use the proper tools to prevent damaging the racks or the fasteners that hold them together. Many servers and networking components come rack ready. That means they're specifically designed to be placed into an equipment rack. Let's talk about rack placement. When designing a room that is going to hold multiple racks of computing systems, some thought needs to go into the placement of those racks. HVAC and rack placement should be done concurrently. Heating, ventilation, and air conditioning systems should be designed to control both heat and humidity levels. When multiple racks are going to be installed, creating a hot aisle, cold aisle design is recommended. The hot aisle is the side of the aisle that receives the exhaust airflow from the computing equipment. This aisle should face an HVAC air intake. The cold aisle is the side or aisle that the air intakes of the computing equipment face. This aisle should face an HVAC air vent. Also, whenever possible, a server room should be designed with a raised floor to help protect against water damage. The raised floor, like a drop ceiling, can also be utilized as part of the cable management system. Let's talk about tool safety. Always use the proper tool for the job. That is what it was designed for. Do not use pencils as a probe. It is possible for the pencil to conduct electricity, leading to an ESD situation or shock hazard. Do not use magnetized tools when working on electrical components, as the magnetic charge can be harmful to the magnetically kept data, and that magnetically charged tool may damage sensitive components. When using compressed air to blow out debris, maintain a minimum distance of 4 inches from the nozzle to the component. Always use isopropyl alcohol to clean products in place of rubbing alcohol. Rubbing alcohol contains a higher water content of approximately around 30%, whereas the water content in isopropyl alcohol is lower. Never use a standard vacuum cleaner when vacuuming electrical components is necessary. Due to the design of the standard vacuum, electrostatic discharges are a common occurrence. There are specifically designed vacuum cleaners that can be used on electrical components. Now, to begin with the MSDS. Part of any safety-first approach to a safe work environment includes knowing what hazards are present in the workplace. Material Safety Data Sheets, or MSDSs, contain safety information on materials and chemicals found in the workplace. An MSDS will contain all known health issues associated with a particular material. It also outlines what protective measures must be taken to reduce risks from exposure and what actions must be taken if the chemical is ingested. The MSDS will also detail the physical properties of the material, as in its flash point or boiling point. And the MSDS will outline the proper steps to take when disposing of it. Each workplace will have its own set of MSDSs, as each workplace is different. It is your responsibility to understand the hazards that are present, so you need to know where the MSDSs are kept for your workplace. It's time to move on to some emergency preparations. Part of any safety-first approach to a safe work environment includes preparing for various types of emergencies. These preparations should be detailed in a set of emergency procedure documents. The procedures should contain escape routes, including where employees will meet to ensure that all are accounted for, information on what type or types of fire suppression systems are present, as well as what steps have been taken to increase the day-to-day safety in the workplace. There are some building layout considerations that concern emergency preparations. All walls should have a minimum 2-hour fire rating. This is the amount of time it takes for the average fire to burn through the wall. Exterior doors and other secure doors must be designed to resist forcible entry. But the doorways should also be designed to be able to handle the amount of expected traffic in an emergency. Fire suppression systems should be appropriate for the type of asset that they are protecting. A wet pipe system is not appropriate for a server room or data center. However, a halon system may not be the correct fire suppression system for an open cubicle area. Backup power should also be incorporated into the building layout. Not all areas are going to require backup power, but for some areas it is going to be essential. Emergency preparations need to include escape plans. Each area or room should have an escape plan map posted in a prominent area, ideally by the main access doorway into that area. This map needs to show the preferred route out of the facility. The map should also include the meeting area outside of the danger zone. This allows for supervisors or managers to account for all personnel. Safety or emergency exits should be clearly marked. They should also be well lit with independent battery power sources. They should be wide enough to handle the expected traffic, and emergency exits should always be kept clear of obstructions. Talking about doors, there are some other considerations. Are they going to be fail open or fail close? So what happens to doors with electronic locks when the power is out needs to be considered. They could be fail close type doors. With this type of door, when the power is cut, the locks engage. These are suitable for keeping secure areas secure in an emergency. Then there are fail open type electronic locks. When the power is cut, the locks disengage. These are suitable for non-secure areas or for areas where two-way traffic is going to occur in an emergency. In many facilities, fail close type fire doors are used. Usually they're kept open by electromagnetics. Once the fire alarm has been tripped, the power is cut to the magnets and the doors swing closed. They usually do not lock when closed, but are used to help slow the spread of fire or other dangers. Another emergency preparation that should be considered are emergency alert systems. All facilities should have an emergency alert system installed. It is usually required by local building codes. These are your fire alarms and whatnot. Combinations of sound and light have proven to be highly effective. In some situations, it may be advisable to connect the facility to the National Emergency Alert System. Now that